Okay, so the first thing you have to understand is the nature of an absolute value problem. So when I have all this written right here, basically what I'm saying is I don't care what's inside the absolute value bars. That's why I didn't put a specific example. I just wrote ax plus b because it could be anything. I mean, it could just be a plain number or it could be, an algebra expression. It doesn't matter what's inside. What does matter is that there's nothing on the outside. You have to get it down to where it's just an absolute value bar, and then it can be a less than symbol, an equal, or a greater than, or a greater than or equal. It doesn't matter what the symbol is. We'll start off right here with equal, okay? And then you're going to have a number out here, okay? And what this is saying, the way this translates into words is this thing, the stuff that's around the absolute value, that's like a starting point. Now, and we're talking about on a number line. We know that this whatever is inside that absolute value bars, that's going to get us somewhere on the number line. Now, I don't know where on the number line because I could be anywhere on the number line, but this is saying that wherever my starting point is, I want to go. This says I want to go this far away. This right here is a distance. Okay, so when you do something simple, let's do something simple, like the absolute value of -2. Since there's no variable in there, that is our starting point is at 0, okay, because there's no x in there. It's the presence of the x that moves us off of 0. So there's no x in there. When we say right here that the absolute value of -2 is 2, what that means is that when we're over here at -2, the distance between these two things is 2. So this is saying how far away from 0 is -2? It's 2 units away. Because it's a distance, there's no direction. When we say, what's the absolute value of 2? This is saying how far away from 0 is 2? It's 2 units away. There's +2. So there's always, when we give a distance, whenever this thing right here is a distance, it has to be positive because there's no such thing as a negative distance. When I pull up this ruler right here, there's no negative signs on this ruler because if I measure how far it is from here to here, that's a positive number. Even if I measure from here to here, it's still a positive number. There's no negative numbers on rulers. So when I have an algebraic expression, something like this, 2x plus 1, and I'm saying this right here, since 2x plus 1 is not just a number, I don't know exactly where my starting point is. I can erase. Oh, I got to use my pen to erase. Hold on. I was using my mouse. Oh, I erased my line. I didn't want to erase my line. It's okay. I can draw another line. See? Uh-oh, I'm still got the eraser going. So, when I have an algebra expression right here, the only thing that changes is that I don't know where I'm starting from. I don't know where I am. At some point you will learn how to do that. But what this is saying is wherever my starting point, wherever I'm starting, I am 3 units away. So even though I don't know where I'm starting from, I know that I want to go 3 units away. And this is my starting point right here, your starting point. I can go 3 units away on both sides. I can go 3 units away on the right and I can go 3 units away on the left. So the way we say that, because you can go to the right and you can go to the left, that's why, and you can't solve a problem if it has absolute value bars on it. So we drop the absolute value bars and we say we're going to go This is our starting point. This says we're going to go 3 units to the right. This says we're going to go 3 units to the left, because when we go left, we generally think about, when we move to the left, we're going a negative. The negative in this case is telling me direction, and this is distance. When it's the absolute value bars are still around it, this is a measurement, and that's why it can't be negative. Okay, and in order to solve it, you have to drop the absolute value bars, and then you say, when you set it equal to the +3, this +3 is a direction. It means you're moving to the right from wherever your starting point is, and this -3 right here means you're moving to the left from wherever your starting point is. That's why we have two different answers. And to solve that, of course, you go -1, -1, and this is 2x equals 2. So divide by 2, divide by 2. So we ended up at 1 over here. So this was where we started from. This was 1. And then over here we do -1, -1, and we get 2x is equal to -4. And divide by 2, we get x is equal to -2. So this thing over here is at -2. Whoops. So +1 and -2 is where we end up if we go 3 units on each side. So you could kind of back that up now and figure out where we started. And I think we started at, I think this is -1/2, I think. And then anyway, so but that is why you can't have a negative number. That's just why C can't be negative, because C is a distance. Once the absolute value bars are solved for, if C is negative, C must be positive, because it represents a distance. If that doesn't help, let me know, and I'll try to find a different way to explain it, or maybe find a different video, but maybe that'll help.